So far, we have just been concerned with the probability of one event occurring. Now we will consider the probability that event A or event B occurs. So the key word here for the addition rule is or. And this is the inclusive or. In other words, it means A or B or both. That's what we mean by the inclusive or. So this represents a compound event. A compound event, any event combining two or more simple events. So we could have A or B or C or D or any combination of those. But we'll just start with two events that have been combined together into this one compound event. Now our notation will look like this: probability A or B. So we see the word or and we know this involves the addition rule. So in general, for the addition rule, you want to find the total ways. Let's see, move this up a little bit. In general, we want to find the total number of ways A can occur and the total number of ways that B can occur but don't count outcomes twice. The formal addition rule corrects for any double count of outcomes. So the formal addition rule is written as the probability of A or B, there's our keyword or, is equal to the probability of A plus the probability of B, and here's where we make the correction for any double counts, minus the probability of A and B. Notice the word and there. The probability of A and B is when A and B, let's write that down, the probability of A and B, that's where A and B occur at the same time. Okay, so let's look at a really simple example. And we want to, let's see, for our example, we will roll a fair die. Okay, and one way to visualize this is using what's called a Venn diagram. So this big rectangle represents my entire sample space. And let's say I want my event A to be an even number. So event A I'll represent with this circle, and this is an even number, like 2, 4, 6. Those are the numbers that would fall in there when we roll a fair die. Maybe I should back up and remind us what our sample space is here. Remember, we can get a 1, a 2, a 3, a 4, a 5, or a 6. So here's our sample space. Well, if event A is roll an even number, the outcomes that fit in event A are 2, 4, and 6. Okay, now let's look at, pick another color here, event B, and we'll let that be a multiple of 3. So the multiples of 3 are 3, 6, 9, 12, 15, but in our group it's just 3 and 6. So since 6 is in this circle, but it's also in my B circle, I'm going to make it fall into my B circle and put in here also my other multiple of 3. So in the blue circle I have multiples of 3, 3 and 6. In my purple circle I have even numbers. Now this green box is supposed to represent my sample space, so there are still some other outcomes that don't fit into A or B, and that would be just anywhere out here I could write this. The number 1, we have 2, we have 3, 4, and the number 5. So they're going to be out here somewhere in the sample space. Okay, so now I could compute the probability of A. Whoops, I wanted to pick this color. Okay, probability of A, the number of ways A can occur over the total number of simple events in the sample space. So how many ways can I get an even number? Well, we've got 1, 2, 3 outcomes in our circle out of the total number of simple events in our sample space, and that is 6. So that reduces to 1/2, or I could leave it at 3, 6. The probability of B, the number of ways that I can get a multiple of 3, well, there are 2 ways, I either get a 3 or a 6, out of 6 total outcomes in my sample space. And of course that would reduce to 1/3. Okay, so the probability of A and B occurring, now remember what we said, that was A and B is when both A and B occur, right? You roll in the die and your result is an outcome that is both in A and in B. And when we look, the only one that outcome that would result that in both A and B is 6. So there's one way out of 6 possible outcomes to get an even number that's also a multiple of 3. So now we can compute our probability of A or B that's equal to the probability of A plus the probability of B minus the probability of A and B. Okay. So we said the probability of A, and I'm going to use my fractions that have not been reduced so I have the same denominator, was 3, 6. The probability of B was 2, 6. And the probability of A and B was 1, 6. So the probability of A or B is equal to 3, 6 plus 2, 6 would be 5, 6, minus 1 would give us 4, 6. And now when we look back at our sample space, that should make sense. The probability of A or B or both is 1, 2, 3, 4 outcomes out of a total of 6 possibilities. So that makes sense. You can see that if we just added the probability of A plus the probability of B, our answer would have been incorrect. 5, 6. There are not 5 outcomes that result in an even number or a multiple of 3. And why? Because when we counted these 3, we counted the number 6. When we counted these 2, we counted the number 6. So we have double counted this overlap here, that number 6, that one outcome, so we have to subtract one of those double counts so that we only end up counting it once. So that's what we mean by don't count any outcomes more than once. if we use the formal rule for probability of A or B, the formal addition rule, it will always make sure that we correct for any double counting. Okay, well, let's look at another similar example that shows us something slightly different. Okay, in this example, we'll roll a fair die. And of course, our sample space will be the same. But now our Venn diagram is going to look a little bit different. Here's our sample space. But in this case, event A is going to be an odd number. And event B is going to be a number greater than 5. Okay, so our odd number group is going to have the numbers 1, 3, and 5 in it. And number greater than 5, when we look at our outcomes here, there's only one value greater than 5, and it's not an odd number. The number 6 would be over here. What have we not accounted for that would still be in the sample space? The number 2 and the number 4. Okay, so this is a Venn diagram of our problem here, where A is the event that we roll an odd number, B is the event that we roll a number greater than 5. So now the probability of A or B is equal to the probability of A plus probability of B minus the probability of A and B. Okay, so this time the probability of A, how many ways can we get an odd number? There are 3 ways out of 6 possible outcomes. How many ways can we get a number greater than 5? Well, there's 1 way out of 6 possible outcomes. And how many ways can you get an odd number and a number greater than 5? Well, there are no ways to get that, right? So in this case, 0, of course, divided by 6 is 0. And so what we find is we could just directly add these two and get our result of 4 out of 6. 4, 6. Notice 1, 2, 3, 4 outcomes are either A or B or both. Now what's different here is that our circles did not overlap. These events, when they do not have when the circles do not overlap or they do not share any outcomes, these events are called disjoint events. Disjoint events, or another name for that is mutually exclusive. Events. They have have no outcomes in common. Visually, in a Venn diagram, they do not have any overlap. So when that's the case, you know, if you are certain that's the case for disjoint events only, then we can find the probability of A or B by just adding the probability of A plus the probability of B. Because we know there is no overlap, we won't be counting any outcomes twice, since none of the outcomes in A are in B, none of the outcomes in B are in A. But you have to be careful. Do not use this formula if you aren't sure whether that they are disjoint. It's only if they're disjoint that this will work. A common mistake is to not realize that there was an overlap, and therefore the probability you calculate is incorrect.